Good day everyone, we are the Group 7 from BSIE 3103, which contains the name of Clarizza Berania, Jenie Lyza Frogosa, Melody Mercado, and Kyla Oblea. For today's video, we are going to present the final requirement in IEE 401 Elective 1, which introduced the Elevating Conveyor. In this video, it will show you the Solidworks tutorial that involves the process of assembling the parts and applying the motions of the elevating conveyor.
So for the assembly part, I will first create a new document and choose the assembly. So our group already prepared all the parts that we will be needing in this activity. So let me just start first with the frame. And then I'll right click this frame and then choose the float. So using the mate, I will mate the front plane of the document, the assembly tool, and then the front plane of the frame. Then make a relation coincident, and then I will do the same thing with the right planes, and then make coincident. And also the same thing with the bottom part. So I'll just click on the surface, bottom surface of the feet and the top plane, and make coincident. The next is I will proceed on inserting another component, which is the screw, and then let me place it here first, and using the mate again, I'll click on this part and this part and make a relation coeccentric, and click OK. And using the advanced mate, the width, I'll click on this surface, the side surfaces of the frame and the side surfaces of the screw. So as you can see, it is already centered. So I will do the same thing to this part, but rather I will use the copy with mates tool. So I'll just click on this part, the screw part, and then next, and I will select this and click on the surfaces of the frame, then click OK. So I will insert another component, which is the conveyor belt. And I will show first the sketch 2 of the frame and the sketch 2 of the conveyor belt. Show. And then using mate again, I will click on this 2 diameters and make relation coincident. And I will do the same thing with the upper part. Click on these 2 surfaces and make coincident. And I will just hide the sketches, and now I will show the sketch 3 of the conveyor belt, because I will be needing that in the next step, which is inserting the step part, and I'll go to front plane and sketch. So from this area, I will click on the tool and I will search for this fit spline in the spline tools. So using the tool, I will click on this lines, curves. And then click OK. So I'll just exit the sketch and proceed on using the mate again. So now I'll go to advanced mate and search for the path mate. So using the path mate, in the component vertex, I will click on this point, and for the path selection, I will click on the spline. And from the bottom part, I will go to pitch yaw control and click on the follow path and click on the Z and OK. So as you can see, it is already not yet fixed, so let me fix that using mate and making the relation coincident with the front plane and the right plane of the step part. So coincident and then OK. So as I drag the mouse, the step part follow the path of the spline. So next thing is I will proceed on the curve driven component pattern, and for this direction 1 I will choose the spline and then reverse the direction. I will change this 2 to 12 items and with equal spacing. So for this components to pattern, I will click on this step, and I'll click on this tangent curve and offset the curve, and then click OK. And now I will dissolve this local curve pattern 1, dissolve pattern, and I'll highlight all these parts and add it to a new folder, which I rename to steps. So next, using the mate again, I will use the path mate again this time. So basically, I will just repeat the step that I did a while ago in this part to the other parts. So I will click on this point and this spline and follow path Z, then click OK. So I will repeat that process 10 times more. So yes. So after that, I will just check if there are 12 path mate in total. So 1, 2, So yeah, there are 12 pathmates, so I will just proceed on the next process. Oh yeah, wait, before that I will mate again. So for this part, I will click on the front plane, and then I will click on this multiple mate mode, and then I will click on all the right plane of each step. Then make a relation coincident. Click OK. So for the last step of this assembly part, I will insert the last item, which is this one. I will just put it here and go to mate. I'll click on the surface and look for the front plane and parallel, make parallel, and click OK. So I will just move the item here, and then I will click here to change the view to hidden lines view visible. So let me copy the cylinder and place it here. Place it here and also in this area. And then I'll change it back to this view, and this time I'll use again the mate, advanced mate, and clip. So I will just select the inside surface of the frame, inside surfaces of the frame, and the edge of the cylinder. I will click OK, and I will repeat that process in these two atoms. So with OK. So basically that's it. That's pretty much it for the assembly part, and it is already ready for the next step, which is the motion study.
So moving on to the next step, we will make this motion study. So let me just check it, then okay, we have it, motion study. Then click this motion analysis, then add gravity, click Y and check, and then move it to 14 seconds. And then disable this, then click this path mate motor, then click a mates, then one path mate, then reverse it to its way, then change this to 75, then click. Then we will just repeat this and apply this to all path mate depending on its way of motion as we desire. So we will just continue doing this as you can see at the picture. and then click this, then check this use contact groups, then click the cylinder, next the conveyor, then change this to aluminum, then check, then click this again, check, then click the cylinder and the step 1, then let me just change this to aluminum, then apply this to the other cylinder and steps. So you can see, we just click this and check. Then for the last one, we have this third cylinder, then step 3, then aluminum, then check. And now we will calculate this. For the meantime, let me share you why we should done this. The reason we do this is to figure out what needs to be done to eliminate inefficient and unwanted motions so that work can be performed on time. As an IE student, we intend to utilize a relevant technology such as this time motion study in Solidworks, which will make work more efficient. It enables us to figure out how to optimize processes and boost performance. More importantly, the calculation in motion study guides us in modifying and stabilizing out a production or process in order to improve future resource efficiency allocation. On this calculation, we can see the motions we apply is working. Let me show you the result of motion study. As you can see, it will move like this after applying motion study with smooth and consistent motions. As a result of this, we have gained and adopted insights about this activity which will be useful in the future, and we hope that you have learned something as well, thus all viewers can benefit. Thank you for watching and goodbye.